everyone. Welcome to section 9.4a. We're going to talk about a way to solve quadratic equations by completing the square. So we've already done two methods to find solutions. Remember, solutions are what go in the swirly brackets. When we are factoring, that's where we factor it, set each one equal to 0, and solve. When we're graphing, we're talking about the x-intercepts. We're going to complete the square, which is going to feel a lot like vertex, putting a quadratic into vertex form. And then when we get into section 9.5, we'll talk about the quadratic formula. So we have checked off factoring and graphing, and today we're going to talk about completing the square. We've got a section 9.4a and a 9.4b. So completing the square is a method used to solve a quadratic equation. It turns a trinomial, 3 terms, into a perfect square binomial. Uh-oh, look at it. Better fix that. To a perfect square binomial. This is from when we were doing vertex form. I'll put similar to vertex form. And this is where we would go to a factoring shortcut. Again, I feel like with us having done that vertex form thing, this is going to be really ridiculously exactly what you've done before. So remember when we do this scooching thing and we take half of b and then take that answer and square it? Well, what's our half of b in this problem? It is -5, right? Square that, you get a 25. Well, I've already got this 25 out here. So this is ready to go. I don't have to do anything except, because if I did add 25 and subtract 25 like how we did before, I would still have an x squared plus 10x plus 25 plus 0. So I've got exactly the same thing. So if this number matches my half of b squared, that means I'm ready to just do my factoring shortcut, which remember is always the squared on the outside. My variable goes here, and my half of b goes here, including the sign. So inside my parentheses for this case, I would have an x and a -5 squared. You guys already know how to do that. We've done that before. And I should put y equals blah, blah, blah. Before we had 0 equals, y equals. We can switch those as long as it's equal to 0. Please make sure it's equal to 0. So steps to complete the square. This is going to feel like putting an equation in vertex form. Make sure it's in standard form, either equal to 0 or equal to y. Find your a, b, and c. Write them, don't write them, but be able to identify them. Scooch your c over, put parentheses around the first half of the problem. Find your half of b and square it. Add that value inside the parentheses, subtract it outside the parentheses. Do you feel like we've done this before? I know I'm going fast. Hit pause if you need to, but we've done all of this back in section 9.2b, I think it was. It was a b, I know for sure. And then go ahead and write the trinomial as a perfect square binomial. This is our factoring shortcut right here, this last step. And this will be our variable and our half of b. So we've done all of this, and then we'll talk about the solving part in just a second. So let's do a quick practice. First of all, if I gave you this x squared minus 12x plus c, it says to find the value of c that makes it a perfect square. So in other words, what do I need to put there? So if I just concentrate on this part, what is half of b? Well, half of -12 is -6. Square that, and I get 36, right? So I'm just going to make it that 36, just like in that last slide, we had a plus 25 already on the outside. If I add 36 inside and subtract it outside, I still am going to end up with the same thing. So if I make it a plus 36 and ignore those parentheses, that means when I go to factored form, what goes inside my parentheses? An x and a -6. So we're doing exactly the same thing. The only difference is those parentheses around the ax squared plus bx. So let's complete the square. Notice it's y equals all of this stuff. So we're just going to complete the square, and then we will solve in just a second. So if I'm going to complete the square, I'm going to scooch this over. I'm going to leave room for something to add inside and subtract outside. How do I know what that add inside and subtract outside is? So half of my b is 3, square that, and I get 9. So plus 9 and subtract it outside. If I give you 9 Reese's Pieces and I take all 9 away, you're back to what you started with. Nothing has changed except now you're just mad at me. So that means I'm going to have a y equals. I'm going to do a little bit of factoring shortcut here. What goes inside my parentheses? And my half of b. And my math problem at the end, 15 minus 9 is a 6. So I just completed the square. So when we go to solve these on the back of the page, we're going to do the same thing, only we're going to replace that y with a 0. And then we can solve. If we've got 2 variables, we can't solve. If we've got 1, we can do that. So now finish the problem by solving. So make your equation, I'm going to add a little, oh, actually, I guess I did. Make sure your equation is equal to 0. In other words, if it's a y equals, change it to a 0 equals. Before you even do the work, I should have said to make sure it was equal to 0. Isolate the parentheses. In other words, get that plus or minus that's sitting at the end, that would have been the k part of our vertex. Get that to the other side of the equation. Take the square root of both sides of the equation, because remember, when you are squaring something and then you square root it, you cancel those two things out. And when you go on one side, there's a little trick. This is important. Make sure you pay attention to the positive and the negative. There are 2 answers technically when we take the square root of something. And last but not least, finish off the problem and solve. So let's do an example or 2. Let's do example 3 and example 5. So example 3, it says to solve c squared minus 6c minus 7 equals 0 by completing the square. So first of all, big star right here, right? It's equal to 0. That's what we like. I'm going to identify my a, b, and c. I'll write them this time. What's my a value? What's my b value? And c. So I'm going to scooch. And I know that I am going to add something inside the parentheses, and I'm going to subtract that same something outside the parentheses. What will that something be that I'll add inside and subtract outside? Half of -6. Square that, and I get 9. So I'm going to plus 9 inside. I'm going to minus 9 outside. So factoring shortcut. So my factoring shortcut then, I'll have my variable and my half of b inside those parentheses. So c minus 3. This is a math problem right here. What's a -7 minus 9? All right. So we got as far as making sure our equation's equal to 0. We completed the square. We're going to isolate the parentheses. So in other words, if I want to get this by itself, I have to get rid of that -16, right? How do I isolate the parentheses? Add 16 to both sides. It sounds very technical, but that's all that is. Once I isolate the parentheses, I'm trying to get to this c. So I'm going to get rid of this squared. What do we do to get rid of squared? The next step in our steps, square root both sides. Here's the cool thing. Square rooting and squaring cancel each other out, so I'm just left with a c minus 3. Don't do more work than you need to right there. Square root of 16, everybody knows what the first answer that comes to mind is what? However, It's a positive and a negative. Because if I take positive 4 times positive 4, I get a 16. But if I take negative 4 times negative 4, I get a 16. So this is the sneaky thing. 2 answers when square rooting. Positive and negative. And I just put that little plus or minus out there. And then our last step is to solve for the variable. We have 2 problems to do. C minus 3 equals positive 4. C minus 3 equals negative 4. 2 simple equations to solve, but we just have to make sure we do them both. So I'm going to add 3 for everything. So for this side, I've got a positive 4 plus 3 is 7. For this side, I've got a negative 4 plus 3 is negative 1. So 2 possible answers. So if I had given you this equation and said solve it by graphing, your parabola would touch the x-axis at 7 and negative 1. Those would be our x-intercepts. If we solved it by factoring, we'd get 2 sets of parentheses that we would set equal to 0 and solve. If we solve by completing the square, we'll get the same answer. It's just a different method to get there. The one thing about completing the square is that your a value must be equal to 1. If you've got some crazy a value, you cannot use this method. And let's skip example 4. Let's go, and by the way, example 4 looks to me like it's not equal to 0, so I would add 10 to both sides. But example 5, it says solve m squared minus 24m plus 9 equals 0, completing the square. Big hint, round to the nearest tenth if necessary. I think we're going to have decimals. So first things first, it is equal to 0, unlike that last problem. Identify A, B, and C. What's my A? What's my B? And C. This is not already a perfect square trinomial, so I'm going to scooch. And I know that I'm going to add something inside the parentheses, and I'm going to subtract that same something outside the parentheses. What value is it that I'm going to add inside and subtract outside? Well, half of my b value is negative 12. Square that. I get a positive 144, which means I have to subtract 144. Ready for a factoring shortcut here. Now that I've got that in there, what is my variable, my half of b? How's an m minus 12 look? What is this answer to this math problem? Positive 9 minus 144. I think it's a negative 135. So we just completed the square. We could identify the vertex if we wanted to, but I really just asked you to solve it. So we're going to have to isolate the parentheses. If I want to get these parentheses by themselves, leave this alone, what do I have to do first? Add 135. So I'm going to have an m minus 12 squared equals 135 when I add it to 0. Next thing, I'm trying to get to that m. So I'm going to have to get rid of that second power. How do I get rid of that squared? Giant square root, because remember, a square rooting and a squaring undo each other. So I'm just left with an m minus 12. Square root of 135, I do not believe that's a perfect square. It says to round to the nearest tenth. Go to your calculator, type in a square root of 135. I got 11.6. And what did I forget to put on my 11.6? When I square root my answer, I've got 2, or when I square root my 135, I've got 2 answers. So don't forget that's positive and negative. So now I've got 2 math problems to solve. M minus 12 equals positive 11.6. M minus 12 equals a negative 11.6. 2 one-step equations to solve. So I'm going to have 2 answers. They're both going to be decimals. They're technically irrational, right? I rounded these guys off. 11.6 plus 12 is a 23.6. A negative 11.6 plus 12 is a 0.4. Double check my math on that one. I'm allowed to have decimal answers. That's really no big deal, as long as I complete the square right. So Last but not least, here's what I would like you to explain in your own words. After you complete the square, how do you finish solving? So once you've got, say, x plus 2 quantity squared minus 9 equals 0. Explain what would you do to finish solving that. I want to know what two possible answers there are for x. And here's your practice problem. Just like the one that I just wrote down for the lesson summary, if you want to explain how to finish solving the practice problem instead, you could do so or use the one that I wrote down. You've got some options there. Finish solving. So I'm actually looking for two possible answers for x for the practice problem. So go to the top of the back side of this page and follow the examples or follow the steps. Have a great day. We'll see you next time for 9-4B.